A circle has a radius of 16 centimeters with a possible error of 0.25 inches. We're asked to use differentials to approximate the possible propagated error in computing the area of the circle, knowing that we have this possible error. So let's note first that r is going to be equal to 16. And then let's note that delta r is going to involve this 0.25, and basically negative 0.25 is going to be less than or equal to delta r is going to be less than or equal to positive 0.25. That is, the error could be a little bit smaller than 16 or a little bit bigger than 16. It's just a possible error of 0.25 inches one way or the other. And we typically report possible error as kind of the absolute value of it. And we don't necessarily worry about putting a plus or minus or anything on it. So that's what we have for delta r. And we also know that the area of a circle is pi r squared. Therefore, dA dr is equal to 2 pi r, or dA is equal to 2 pi r dr. And this is how we can rewrite this expression using our differentials. And what we'll assume is that delta A is approximately dA. And we'll use that to try to figure out kind of what delta A might look like. We'll also use delta r to approximate dr. So our delta A is going to be about 2 times pi times 16 times dr. We'll approximate it with delta r of 0.25. And it's really a plus or a minus 0.25. So here we're going to include that. So delta A is approximately, let's multiply this out and we'll convert pi to a decimal. So we'll have 2 times pi times 16 times 0.25, or a difference of about 25.1 plus or minus centimeters squared. That's the potential error in our area. Now if we actually figure out what our area is, our area in this case is pi times 16 squared. So our area is about 804.2 centimeters squared. So while 25.1 square centimeters sounds like an awful lot for an error, it's against 804. So it may not be all that much. In the next video, we'll talk about how to get a better feel for is that a big potential error or not when we propagate it by talking about relative or percent errors.